All right, just as a reminder, you should have already finished pages 12 and 13 before you're watching this video. This video is only to check your answers. So if you have not completed 12 and 13, you need to pause this video, go back, complete the pages, and then you can watch it. All right, so let's go through this and try to solve it. It looks like this is more complicated than it is, but we just need to remember what we know about isosceles triangles in order to figure this out. Okay, so we know that the two legs are congruent, then we know that the two base angles are congruent as well. So that means we know that this angle over here, the unknown angle, is 3x plus 8. Okay, now we need to use the idea that all three interior angles of a triangle add up to 180, and we can solve for x. So we just do 3x plus 8 plus 3x plus 8 plus 2x plus 20 equals 180, and we do 180 because the interior angles have to add up to 180. Now we just go through and add together like terms. So I'm going to add together all my x's. So 3 plus 3 plus 2 is 8x plus, all right, now 8 plus 8 plus 20 is 36 equals 180. All right, now we want to get our x alone, so we minus 36 on the side and we minus 36 on the side. All right, and that's 144 is equal to 8x. All right, in order to get rid of 8x, we divide by 8 to get x alone, and we end up getting that x is equal to 18. All right, and there you have it. Let's go on to our next problem. So now we're using this similar idea. We see that we have an isosceles triangle and the two legs are congruent, so that must mean that our base angles are congruent as well. So if the first base angle is 40, then this base angle is 40 degrees as well. All right, now we just need to use the idea that all three interior angles add up to 180. So we get 4x plus 10 plus 40 plus 40 equals 180. Okay, we add our like terms together, so we add 10 plus 40 plus 40, and we end up getting 4x plus 90 equals 180. Now, in order to get the 4x by itself, we minus 90 on both sides, and we end up with 4x equals 90. And in order to get the x by itself, we take 90 and divide it by 4, and we end up with x is equal to 22.5 degrees. All right, this one's a little more complicated, but we still can do it. All right, let's first start off with ignoring this triangle over here. We don't even have to worry about it. We're just going to look at the main triangle that we have. All right, and we see that it's an isosceles triangle. Our legs are congruent, so our base angles have to be congruent too. So that means that 180 is going to be equal to 54 plus those two base angles, okay? Let's say that this base angle is equal to y. Well, if the one base angle is equal to y, then the second base angle is equal to y because they're the exact same. So we're going to say 54 plus 2y. Now we just need to solve for y. We do 180 minus 54 to get 2y alone. End up with 126 equals 2y. All right, and now in order to get y by itself, we divide by 2, and we end up with y is equal to 63 degrees. So now we know that those two base angles are equal to 63 degrees. So let's go ahead and write that in, 63, 63. All right, so now if we know that this angle here is equal to 63, we can figure out what that angle is there because we look and when we add them together, we get a straight angle. We know that a straight angle is equal to 180. So we just take 180 minus 63, and we know that this angle here has to be 117. So now we have 117 in that corner. We're going to use the fact that that's an isosceles triangle to continue, okay? We know that the two legs are congruent, so we know my two base angles have to be congruent too. So if x is over here, then we know x is over here too. So now we have 180 because we know our three angles add up to 180. So go to 117 plus 2x. We take 180 minus 117 to get the 2x alone. We know it was 63 is equal to 2x. And then in order to get x by itself, we divide by 2, and we get x is equal to 31.5. So while it took us a few steps, we were able to finally get there using our knowledge about isosceles triangles. All right, so now we're going to go through and complete this proof using the given information. So we know that BD bisects angle ADC. This is angle ADC here. Well, the definition of bisects means that it splits the angle into two congruent parts. So basically we know that angle 1 has to be congruent to angle 2 just based on our definition of bisector, right? So we have that those two angles are equal to one another, all right? Our second piece of information is that DB is perpendicular to AC. So we know that by definition, a perpendicular line intersects another line at 90 degrees. So we know that angle 3 and angle 4 have to be 90-degree angles, all right? So our ultimate goal is to prove that triangles ADB, so this triangle here, ADB, is congruent to triangle CDB. Because once we can do that, we know that we can corresponding parts of congruent triangles are congruent, and we can kind of keep going from there. So if you notice, triangle ADB and triangle CDB share this segment in between, right? They both share segment DB, so we know that DB has to be congruent to DB. Why? Because they're the exact same segment. So that's kind of our next conclusion that we would make. And remember, we're just planning out our proof right now, okay? So we know that DB has to be congruent to DB. Well, if you look now, we have angle, side, angle. We have angle, side, angle, and that means our two triangles are congruent. Knowing that those two triangles are congruent, what can we conclude? Well, let me erase all my markings. We know that those two triangles are congruent, so we can conclude that AD is congruent to CD because of corresponding parts of congruent triangles are congruent. Okay, and well, if we just completely disregard this segment in the middle here, you'll see that what we have is an isosceles triangle. And that ultimately is what we're trying to prove. We're trying to prove that ADC is an isosceles triangle. All right, now that we have all of our plan out there, we know exactly what we're trying to do. Let's go through and actually do it, see if we can. All right, so I'm not going to write my given statements in there because it's going to take way too much room and I'm going to run out of room on my slide. But go ahead and pause the video and put your givens in there, okay? But so, we are going to say that angle 1 is congruent to angle 2. And then for a reason why, we're going to put it's the definition of bisect. All right, if BD here bisects this angle, we know that it's going to put it into two equal angles. So that's how we know 1 is equal to 2. Okay, our next thing is that angle 3 and angle 4 are 90-degree angles. And how do we know that? Well, it's the definition of perpendicular. And if they're both 90-degree angles, then they're congruent, right? So now we have measure of angle 1 is congruent to measure 2. We have 3 is congruent to 4, okay? Our third piece of information is that DB is congruent to DB. Why? Because they're the same segment. And then now that we have those three pieces of information, we can say that triangle ADB is congruent to triangle CDB. And the reason why would be angle side angle theorem. All right, so I'm going to erase what I have just because I need more room, but pause it if you need to write it down. All right, so we're leaving off with our two triangles are congruent. So now I can say that AD is congruent to CD, and my reason why is CP, CTC, or corresponding parts of congruent triangles are congruent, right? If those two triangles are congruent, then I can easily say, well, this has to be congruent to that. Okay? And now I know that triangle ADC is isosceles. And the reason why is just the definition of isosceles, because the definition of isosceles tells us that we have at least two congruent sides. And if you look at this big triangle here, you'll see it has two congruent sides. So we're just going to say the definition of isosceles. And there you have it. All right, so now we're going to go through and we're going to see if we have enough information, okay, to figure out our question marks. And we do, okay? So let's look here. We know that my triangles and isosceles, my legs are congruent, so my base angles have to be congruent. So that means that this has to be 50 degrees. And then in order to figure out this third angle, we just use the fact that interior angles have to add up to 180. So if this is 50 and this is 50, we're up to 100. So angle B has to be 80 degrees. All right, if we look at triangle ED and F, we see that the base angles are congruent. So we know that the sides, our legs have to be congruent. So if EF is 5 centimeters, then DF is 5 centimeters too. In number 4, triangle GHJ is equilateral because all three sides are congruent. So that must mean it's also equal angular. And if something's equal angular, all three angles have to be congruent. Because the three angles have to add up to 180, then angle H has to be 60 degrees. Because if it was any different, then it wouldn't make it to 180. All right, let's figure out if we can prove the triangles here are congruent. All right, let's look at number 5. Well, I'm going to add my ticks on MQ because I know that both of my triangles MNO or MNQ and MPQ share the segment MQ. So that must be congruent. So now if I look at it, let me erase all my lines. I have two sides and an angle. But when I see that my angle's not in between my sides, or else it would be angle M and angle Q are congruent. Instead, it's out to the side, so I see that I have ASS, which we know isn't enough information. However, I see that these two triangles are right triangles. So based on that, I know that I have a theorem that helps me prove right triangles are congruent. It's called the HL theorem, or the hypothesis leg theorem. Well, here's my hypothesis, or my hypotenuse. My hypotenuse is congruent to the hypotenuse of another triangle, and I have a leg that's congruent to another leg of a triangle. So it looks like these two triangles are congruent based on the hypotenuse leg theorem. All right, let's go on to number 6. It looks like I know that all three angles are congruent, so I have AAA. Unfortunately, this isn't enough information because I don't know anything about the length of the sides. I know that my three sides have to be congruent to each other, and I know that these three sides have to be congruent to each other, but I don't know that this side UW is congruent to this side ST. I don't know because I don't have enough information. Let's look at number 7. Well, in number 7, I know that angle D has to be congruent to angle F, which has to be congruent to angle E because it's equilateral, so it also has to be equal angular. However, I don't know that angle D is the same measurement as angle B. So unfortunately, we cannot conclude that these two triangles are congruent. We don't have enough information. All right, let's keep going. So number 11, we see that we have another side that we could fill in with ticks because we know that they share the same segment. And we know that these two angles, because they're the base angles of an isosceles triangle, have to be congruent. However, we do not know that this angle is congruent to this angle because they have a different amount of arcs. So unfortunately, we don't have enough information that these two triangles are congruent. Let's look at number 12. I can add an extra 2 ticks on line AC because they share it. But other than that, I only have two sides, right? 2 congruent statements about sides. I don't have a third piece of information. So even though this looks like a right angle, I can't say it is because it doesn't have the square in it. So unfortunately, we don't have enough information. Let's look at number 13. Well, I know that these triangles are all equal angular, which means that all of these angles are 60 degrees. Okay. And then I also see that these two triangles share the segment FG. So I know FG has to be congruent to FG. So if you look, I actually have angle, side, angle. So I do have enough information. Yay, they're congruent. You could also say that they both have angle, angle, side. That could work too. All right, last three. So if we look at number 14, we see we have one side's congruent to another side, so side. We have a second side's congruent to a second side, so another side. And then we have an angle here. So we have two S's and an A. And if you notice, our A is in fact in between our S's. So we have SAS, which is one of our congruence theorems. So we can say, yep, they're congruent. All right. So on these two triangles, we can add another set of ticks on the segment KL. Because KL is shared in both triangles, it has to be the same length. And we know that if MLK is 90 degrees, JLK has to be 90 degrees as well, because together they make up a straight line, right? So it looks like we have an angle and two sides. Well, you'll notice that my angle is not in between my two sides. So right now I have ASS. However, if you look a little bit closer, we have the hypotenuse is congruent to another hypotenuse, and we have a leg is congruent to a leg, and we are dealing with right triangles here, so we actually do have enough information. We can use the HL, or hypotenuse leg theorem. And number 16, we know that AC has to be congruent to CB because the base angles are congruent. And we know that ED has to be congruent to EF because the base angles are congruent. However, we don't have enough information to conclude that AC is congruent to ED because we just don't know that, unfortunately. So we don't have enough information. If you have any questions, please call Ms. Hagberg over, but those are the answers to pages 12 and 13.